Pluto is a far-off and confounding minor planet, once taken into consideration a part of our planetary organization's family. But recent alarming announcements by leading astrophysicists Neil deGrasse Tyson and Michio Kaku have brought Pluto back into the spotlight with an extraordinary revelation. They suggested that this chilly world is on a collision course with Neptune. Yet how could this happen? And what might be the consequences of such a significant event? Are we witnessing an exciting cosmic eccentricity, or is there something more to this approaching, seemingly limitless impact? Join us as we investigate the potential outcomes of a Pluto-Neptune collision. Pluto, a former planet that was reclassified as a dwarf planet, is relatively enigmatic due to its odd orbit. It remains a subject of interest and ongoing study within the astronomical community, according to recent predictions by leading experts. Pluto's trajectory is dangerously close to Neptune's. Neil deGrasse Tyson and Michio Kaku are both raising the alarm about a potentially catastrophic collision between these two celestial bodies, one that could even pose a serious risk to Earth. How is such an event even possible? Pluto's journey around the Sun is unlike that of any other planet in our solar system. It requires an incredible 248 years to complete a single orbit, meaning that since its discovery in 1930, it hasn't even finished one full revolution yet. But the intrigue doesn't stop there. Pluto's orbit is marked by an astoundingly curved form, veering far from the nearly circular orbits of the major planets. What makes Pluto's orbit even more remarkable is its 17 inclination to the ecliptic plane, the main orbital plane of our solar system. This steep tilt sets Pluto apart. One of the most fascinating aspects of Pluto's orbit is its crossing point with Neptune's orbit. For roughly 20 years during each orbit, Pluto actually comes closer to the Sun than Neptune, defying what we would expect based on their positions in the planetary lineup. This naturally raises a question. Why hasn't Pluto collided with Neptune? The answer lies in the gravitational influences of other planets. The study of Pluto's orbit began soon after its discovery. Initially, astronomers tried to determine its precise orbital path. Unlike other planets whose orbits lie mostly near the ecliptic, Pluto's steep inclination and elliptical shape made it stand out. The mystery deepened when it was confirmed that Pluto's orbit does, in fact, cross Neptune's. Yet Pluto's orbit has remained stable, a testament to the complexities of celestial mechanics. The three-body problem in astrophysics involves determining how three bodies like Pluto, Neptune, and the Sun move and interact with one another through gravity. Pluto's orbit is turbulent. Minor deviations in initial conditions can lead to significant differences over millions of years. Yet, Pluto's unusual orbital characteristics have been shown to maintain stability over extremely long timescales, keeping chaos in check. Recent simulations have helped us understand how the giant planets Neptune, Jupiter, and Saturn influence Pluto's path around the Sun. Jupiter's immense gravitational pull is strong enough to keep Pluto on a relatively stable course for billions of years. These forces are essential in preserving the order and balance of celestial dynamics. Without them, our solar system would be a place of far greater unrest and unpredictability. Pluto's orbit is a remarkable example of celestial mechanics, displaying both stability and chaos within our local planetary system. The unique characteristics of its orbit, influenced by the gravitational forces of nearby planets, especially Neptune, highlight the intricate and dynamic nature of space. Predicting major astronomical events, particularly those involving chaotic orbits like Pluto's, presents immense challenges. The inherent unpredictability of such systems means long-term forecasts are often riddled with uncertainty. While numerical simulations provide powerful tools for understanding and predicting the behavior of celestial bodies, they also underscore the limits of our predictive abilities. So, Why are prominent astrophysicists only now expressing concerns about a possible crash between Pluto and Neptune? Despite the various complex forces working to prevent such a scenario, Neil deGrasse Tyson and Michio Kaku, both renowned figures in astronomy and theoretical physics, have voiced concerns about a potential collision. If Pluto and Neptune were to collide, it would be both fascinating and catastrophic for our planetary system. The impact could unleash immense energy, likely shattering Pluto due to its smaller size and icy composition. Debris from the collision could scatter throughout the solar system, potentially threatening other planets and their moons. For Neptune, such a collision could alter its atmosphere and possibly its orbit, depending on the specifics of the crash. Michio Kaku, a distinguished theoretical physicist known for his work in string theory, brings a unique perspective to the discussion. Views on the future of space exploration and the connection between celestial mechanics and theoretical physics offer valuable insights into the mysteries of cosmic dynamics, understanding the complex gravitational interactions and orbital behavior of celestial bodies like Pluto can yield critical knowledge for future space missions. This understanding can aid in navigating the solar system more effectively, predicting potential hazards, and even planning missions to the outer reaches of our cosmic neighborhood. And beyond, the lessons learned from studying Pluto's orbit can be applied to exploring other celestial bodies, providing a roadmap for how we might approach and interpret distant worlds. When it comes to the physics of planets, celestial mechanics and theoretical physics are deeply interconnected. The motions and interactions of planets, such as the gravitational dance between Pluto and Neptune, relate to the fundamental principles of physics. If these two bodies were to collide, it would mark a monumental event in astronomy, offering a rare observational opportunity that could potentially intersect with string theory. String theory, a theoretical framework in which the point-like particles of particle physics are replaced by one-dimensional strings, aims to explain the fundamental forces and matter in the universe. A Pluto-Neptune collision could create extreme conditions of energy and motion, potentially providing a cosmic laboratory for testing the boundaries of physics itself. Gravity, possibly creating circumstances wherein predictions made by way of string theory could become detectable. For example, extreme energy effect could offer insights into the behavior of fundamental particles and forces under severe conditions, a key area of interest in string theory. While the direct impact on Earth would be negligible because of our distance from the outer planetary system, the scientific implications of such an event could be profound, potentially contributing to our understanding of the essential nature of the universe as described by string theory and other areas of theoretical physics. Pluto's confounding dance across the sun continues to enrapture scientists and enthusiasts alike, providing a window into the complexities of celestial mechanics. While its reclassification as a dwarf planet sparked dialogue and redefined our knowledge of planetary bodies, recent discoveries about its orbit have reignited interest in its function within the local planetary system. Neil deGrasse Tyson and Michio Kaku, prominent voices in astronomy, have raised concerns about a potential crash between Pluto and Neptune, shedding light on the complex dynamics at play in our cosmic neighborhood. Their warnings emphasize the importance of understanding the gravitational interactions and orbital mechanics that govern celestial bodies' movements. Pluto's orbit, characterized by its unpredictability and steep inclination, defies conventional assumptions and challenges our view of planetary motion. Unlike the nearly round orbits of its neighboring planets, Pluto's path follows a unique trajectory, intersecting with Neptune's orbit at points throughout its long journey around the Sun. The gravitational influence of other planets, especially Neptune, plays a crucial role in shaping Pluto's orbit and maintaining its stability over thousands of years. Despite the turbulent nature of its path, numerical simulations and theoretical models play a vital role in predicting the future behavior of celestial bodies and understanding the complex interactions among planets. These simulations show that while Pluto's orbit is turbulent over millennia, if it remains relatively stable within the broader framework of the solar system's gravitational field. The potential for a collision between Pluto and Neptune is proposed by astrophysicists Neil deGrasse Tyson and Michio Kaku, highlights the ongoing uncertainties and intricacies in planetary dynamics, while such an event remains hypothetical and highly unlikely in the near term. The gravitational dance between Pluto and Neptune underscores the delicate balance of forces that govern celestial bodies within our solar system. Beyond its scientific significance, Pluto's study offers practical insights for future space exploration missions. The New Horizons spacecraft, launched by NASA in 2006, provided unprecedented images and data of Pluto and its moons during its historic flyby in 2015. The mission revealed stunning details of Pluto's surface features, such as mountains of water, ice, and vast fields of frozen nitrogen, enhancing our understanding of the geological processes shaping the remote dwarf planet. The success of the New Horizons mission highlighted the technological advancements and collaborative efforts required for deep space exploration. By analyzing Pluto and its moons, scientists gained valuable insights into the diversity of celestial bodies and the environmental conditions present in the outer regions of the solar system. These discoveries have implications for future missions to explore other dwarf planets and trans-Neptunian objects, furthering our understanding of planetary formation and evolution. Pluto's status as a dwarf planet has also sparked discussions about the criteria used to classify celestial bodies in the solar system. The debate over planetary classification reflects broader questions about scientific classification systems and the evolving nature of astronomical knowledge. While Pluto meets some criteria for planetary status, including orbiting the Sun and having enough mass for self-gravity, its classification as a dwarf planet highlights the diversity of celestial bodies beyond the traditional 8 planets. Studying Pluto's orbit expands our understanding of celestial mechanics and planetary dynamics in the outer reaches of the solar system. By analyzing the interactions among Pluto, Neptune, and other celestial bodies, scientists can gain further insights into the formation and evolution of planetary systems. These insights are vital for developing theories about the origins of our solar system and understanding the processes that shape planetary bodies over billions of years. Pluto's discovery and subsequent study have contributed to our knowledge of planetary migration and the formation of the Kuiper Belt, a region beyond Neptune populated by small icy bodies. Studying Pluto's orbit provides clues about the gravitational interactions that may have influenced the formation of planets during the early stages of the solar system. The gravitational influence of Neptune on Pluto's orbit provides an example of how interactions among larger planets can shape the trajectories of smaller bodies over time. Future research on Pluto's orbit and the potential for a collision with Neptune could help refine our understanding of planetary dynamics and improve our predictions about the behavior of celestial bodies. As we continue to explore the mysteries of Pluto and the outer reaches of the solar system, we may discover new insights into the fundamental forces that govern our universe. The collision of Pluto and Neptune, although unlikely, would be a significant event that could offer valuable opportunities for scientific discovery. Whether or not it occurs, the investigation of Pluto's orbit and its relationship with Neptune will continue to inspire astronomers and physicists as they strive to unlock the secrets of our cosmic neighborhood.